Okay, hello. I'm here to talk about adding, subtracting, and multiplying polynomials. Our main goal is to combine like terms. Okay, we want to simplify the expression by combining like terms. Okay, some key vocabulary that we need to know. A variable is just a letter that can be any value. Okay, and it could be x, y, m. It represents any value. Coefficient is the number in front of the variable. In this example, the 3 is the coefficient. 3 is the coefficient of y. Coefficient of negative 5x is negative 5. In this case, there's no number, so it's going to be there's going to be like an invisible 1, and the coefficient will be negative 1. Exponents. Exponents in this case is the power to which the variable is raised. In this case, the exponent is 2. Exponent is 2 for this case. Here there's no number, therefore the exponent is 1. The exponent for m is 1. There's nothing there, so it's like an invisible 1. Okay, we're going to go into adding polynomials. Okay, first example here, we want to simplify this expression, make it a little bit easier to understand. We want to make it more readable. So if we start with x plus 3 plus parentheses 3x minus 5, first thing we want to do, we want to remove this parentheses. There's nothing here, so it's like having a 1. So when we distribute 1 times anything, is just what's inside the parentheses. So for example, here we're going to have x plus 3 plus, this plus comes from here. Okay, it's like having 1 times 3x is just 3x. Here we have 1 times negative 5 is the same as a positive times a negative gives you a negative. That's why we get negative 5. Okay, now what are the like terms? The like terms are the x variables, the x, this x with this x. So we're going to say we're going to rewrite it. Okay, and we're going to have this 3 come over here. We're just rewriting it. Once you get the hang of this, you could save time by skipping this step. And basically we're going to say nothing is here, not the coefficient of this x, there's nothing here, therefore it's like having a 1. We don't put the 1 there, but it's like having a 1. So we're going to say 1 plus 3 is 4. 4 what? 4x. 3 minus 5 is negative 2. Okay, so this expression simplifies to 4x minus 2. Okay, let's go over the example of subtracting polynomials. Okay, when we subtract, we have this example here. We got parentheses 3x squared minus 5x plus 1 minus parentheses 5x squared plus 2x minus 7. Okay, again, we could remove the parentheses. It's like having a 1 here, so it's basically what's going to be inside, because 1 times anything is just whatever we started with. So if we have a 1 here, 1 times 3x squared is 3x squared. 1 times negative 5 is negative 5x, and 1 times 1 is 1. Okay, we're just removing the parentheses. In this case, it's a negative. Again, it's like having a 1 here. We don't have to put the 1 there. So basically what's going to happen is everything inside the parentheses is going to switch signs due to this negative sign. Okay, why does that happen? Negative 1, a negative times a positive gives you a negative. So we get negative 5x squared. Now we're going to have a negative times a positive. Negative times a positive, you get a negative. That's why we switch the sign. Then finally, a negative times a negative, you multiply 2 negatives, you get a positive. That's why this becomes plus 7. Okay, we're going to combine the like terms. Okay, the like terms are going to be the variables that have the same exponent. In this case, which ones have the same exponent? The x squared with this x squared. The coefficient of this is the 3. So we're going to have 3x squared, which is just this variable, minus the 5x squared. Negative 5 is the coefficient of this x squared term. We're going to combine the x variables to the first power. Nothing is here, but it's like having a 1. I just don't have to put that 1 there. Okay, so we're going to say negative 5x minus 2x, and then we're going to get the constant. Constants are just the numbers. We're going to have 1, and we're going to have 7 plus 7. Okay, we're going to combine these two. 3x squared minus 5x squared is negative 2x squared. Okay, here we have two negatives, same sign, so we're going to add and we're going to keep the sign. Minus 5 minus 2 is negative 7x. And finally, 1 plus 7 is 8. So this complicated expression simplifies to this expression. Okay? So I could say I either have $1 or I have 100 pennies. I either have this expression or I have this is the equivalent expression. Okay? So to simplify the steps is we're going to change the sign. Let's review the steps again. Change the signs of all the terms inside the parentheses following the subtraction sign. And then we're going to combine the like terms. Okay, let's look over the final example. Multiplying polynomials. Okay, when we multiply polynomials, we want to keep in mind that the coefficients, when we multiply in a monomial that's to a power with another monomial to another power that's the same base, we just add the exponent. So for example, if I would have x squared times x to the fourth, it's the same base. X and x is the same base, and we're going to add the power. So we're going to say it's the same base x, and we're going to say 2 plus 4 is 6. So this is equivalent to 2 plus 4 is 6. Let me do another example here with another monomial. If I would have 2x cubed times 4x to the fourth, in this case, this monomial has a coefficient of 2, and this monomial to the fourth power, x to the fourth power, has a coefficient of 4. In this case, you have to multiply the coefficients, and you're going to say 2 times 4 is 8, and it's the same base, therefore we're going to say x, and we're going to say 3 plus 4 is 7. So this expression is equivalent to x, 8x to the 7th power. Okay, let's see how we're going to apply this. We're going to look at these multiplying examples. We're going to look at a couple of examples here. We have 4x to the fourth times, because we have a parenthesis, so 2x cubed minus x squared plus 7x. So we're going to multiply this term times all of these. We're going to have to distribute here. Okay, so we're going to say 4 times 2 is 8. 4 plus 3 is 7. Okay, so basically if I wanted to expand this, I would have 4x times 2x to the third minus plus times a negative gives me a negative 4x to the fourth times x squared, and then we're going to have finally positive, and a positive gives me a positive 4x to the fourth times 7 to the x. Okay, so now we're going to say 4 times 2 is 8, 4 plus 3 is 7, so we say it's this expression is equal to 8x to the 7th power. Let's go to the next one. We got a negative here. This negative comes down. We're going to say 4 times 1 is 4. X to the fourth times x squared. You add the two exponents and you get x to the 6th. And here we're going to say 4 times 7 is 28. Going to add the exponents. 4 plus 1 is 5. So we get x to the 5th. Final answer, this expression is equivalent to 8x to the 7th minus 4x to the 6th plus 28x to the 5th power. Notice I cannot combine these monomials because all of these are to a different base. I can't combine this 8x to the 7th with this negative 4x to the 6th. Therefore, what do? I leave it the same, as well as this. I can't combine this with any of these because they're all to different powers. So I have to leave it like that. Okay, let's look at this other example. When I'm multiplying binomials inside of a inside parentheses times another binomial inside parentheses. Okay, what I could do here is I can say this first variable is going to multiply the second binomial in the expression. So I'm going to say x times x minus 2. Okay, and then the 5, this x is this one, this 5 is here. Negative 5 times the second binomial, x to the negative 2. Okay, now I'm going to distribute. X times x is x squared. Again, nothing is here, so this is like having a 1. And I'm going to say x times negative 2 is negative 2x. Go to the next part. A negative and a positive gives me a negative. Negative 5 times x, negative 5x. And we're going to do the second part. We're going to distribute. Negative 5 times negative 2. Multiply two negatives, you get a positive. Again, I'm going to combine like terms. I can't combine the x squared with anything because there's no other x squared. Therefore, I have to leave the x squared the same. Here, you got x to the first power and you got x to the same first power. Okay, so I can combine these two. Okay, so I'm going to look at the coefficients. You got negative 2x minus 5x. Two negatives you add and you keep the sign. It'd be like, for example, if I have 2 apples plus 5 apples, you get 7 apples. In this case, they're both negative there, and I keep the negative sign. The 10 remains the same. Okay, so these are like terms. It could be anything. As long as the variables are the same to the same power, you can combine them.